Okay, to start this problem, I would recommend setting up a drawing. So we draw the normal distribution, and we notice that the mean is 18. That's given in the problem, so we can label that on our normal distribution right here. We also know that 40% passed with the 20, so we can kind of shade in this 40% up here, and we know that our cutoff score, which we have capital X, is 20. So as soon as we do this, we can go to the chart, and we're going to try to find the z-score that gives us 40% in the tail and 60% in the body of the distribution. Okay, this is on page 584. It doesn't show up real well here, but again, we're looking for 60% in the body, so 0.60 in the body, 0.40 in the tail. If we start going down here, we notice the proportion in the body is getting higher and higher, doesn't quite get to 0.6, so we come over to the second set of columns, and here we have 0.5987 proportion in the body. Next one is 0.6026. Either one would be fine. Let's take the 0.5987 because it's a little closer to 0.6. So that would give us a z-score of 0.25. Notice that we could have gone in this column looking in the proportion in the tail to get 0.40, 40%. That would have also given us the same z-score. Anytime you're working with z-scores, ask yourself, should this be positive or negative? Anytime it's above the mean, like we are here, it should be positive. If our cutoff is below the mean, that should be a negative z-score. So we do have a positive z-score of 0.25 from the chart for part A. Part B then is just using that formula that we looked at in class a few times, z equals x minus the mean over the standard deviation. So we know that the cutoff score is 20, the mean is 18, we don't know the standard deviation, we do know that z is positive 0.25 because we just figured that out. So we set up 20 minus 18 gives us 2, multiply both sides by the standard deviation. So on the left we have 2, on the right we now have 0.25 times standard deviation, and divide both sides by 0.25. That gets the sigma all by itself, and we have 8 equals the standard deviation. So the mean test score was 18, standard deviation was 8.